Homework 2.6, Combinations of Functions, Video 5. Homework due Friday, May 22nd, 2020 at 11:59 p.m. In the next couple of videos, we will be discussing topics relating to questions 12, 13, 14, and 15 on Homework 2.6. 2 videos ago, I believe I mentioned that there were 5 ways to combine functions, at least I think I did. And we've already seen 4 of them, adding, subtracting, multiplying, and dividing. But we haven't talked about what the 5th way is yet. And you might be thinking, exponents. And although you technically can do that, it's not the one that we're going to look at. The 5th way to combine functions that we're going to look at is called composition. And I'll tell you right now that function composition is super important at a calculus level. That doesn't mean we can't handle function composition in a college algebra class. But for those of you who are heading towards Calculus 1 at some point in the future, you will see function composition and it will be critical to most of calculus. Don't worry, it's not difficult, it's just critical. So let's take a look at this example and see if we can figure out what's going on. We have 2 functions, not a surprise, we're combining them. Suppose f of x equals 3x plus 5 and g of x equals x squared plus 2x plus 3. Find each function. And if you'll notice, I've got the 2 functions next to each other, but I've got an empty circle between them. Almost like the letter O, but it's not a letter O. And I've got that with both f first and then g first over here. So what's going on? What is that thing? Well, this merits a definition. This is called function composition, as you can tell by the title. Function composition is another way of taking 2 functions and creating a new one. Before I tell you what its definition is, let me tell you how to read this. This little circle, which represents composition, when you read it, you simply say the word of. So the way you would read this function is f of g of x. F of g of x. That's how you would read that. Now, why am I stressing how to read it? Because if you know how to read it, then you are saying its definition. You just have to pause at a different place. Here's the definition of f of g of x. F of g of x equals f of g of x. Listen closely to the words I said. F of g of x equals f of g of x. I said the exact same words. I just paused at a different place. If you wanted to read the right side with emphasis, you could say f of g of x. So for those who happen to be watching this and are math nerds, I kind of use the associative property of quotation marks. That's such a stupid joke. So anyway, f of g of x, by definition, is f of g of x. And what this means is you take one function and insert it inside of another. Now, in the previous videos about function notation, we did do some problems where the input of the function was an expression. So we're about to see that again. The hardest part about this is the setup. Once you get it set up, it's pretty easy. So let's take a look at this first example. Let's find f of g of x for these 2 functions. Here's how to do it step by step. Number 1, write down what the definition says. And again, you just have to read it and pause at a different place. F of g of x equals f of g of x. That's just the definition. So where do we go from here? Well, what do parentheses normally say? Go inside and do that first. So let's go inside the parentheses for the f function and look at the g function. Now, what can we do with g of x? Well, nothing if you don't tell me what number to put into it, but I have to do something. I have to replace this with something that it equals. Well, doesn't it equal x squared plus 2x plus 3? So in your next move, and I'm going to write in words here what's happening, you replace the inner function, the one on the inside. So g of x in this problem is equal to x squared plus 2x plus 3. Okay, now let's do f of that. And remember, we've done functions evaluated at expressions before. That was purposefully for this. So how do we pull this off? Well, remember, there's a gimmick for finding a function evaluated at an expression as opposed to a number. You write this function but use parentheses instead of x's. In fact, let me go ahead and write that as the next step. Write the outer function with parentheses instead of x's. Okay? So we're going to write down the f function, 3x plus 5. But instead of writing 3x plus 5, I'm going to write 3 parentheses plus 5. And guess what's going into these parentheses? The same thing that was in these. X squared plus 2x plus 3. So I'm actually going to follow up this red set of instructions with a semicolon and say, write the inner function. Write the inner function in those parentheses. So you can actually do two moves at once. Set up the outer function and put the inner function into it. At that point, you've created the composition of the two functions. You've basically stuck one function inside the other. But I'm pretty sure the homework is going to expect you to clean up the mess you made, which in this case is the distributive property. So 3x squared plus 6x plus 9. But wait a minute. The minute I write 9, what's going to happen next? Plus 5. So let's just go ahead and do 9 plus 5, which is 14. Look, I made a new function. I stuck one function inside another, and this is the results. It is important to state that the order matters when you do function composition, because the majority of the time you will get different results. There are exceptions, but they are few and far between. So let's find g of f of x doing the same thing. Remember, your first move is to write what the definition is saying. And the definition is, just to read this differently, g of f of x is equal to g of f of x. And now, work inside out. Go to the inside and replace the inner function with what it equals. In this case, f of x is equal to 3x plus 5. Now it's time to work the outer function. For the outer function, we write it, but change each x to parentheses. So instead of x squared, parentheses squared, instead of plus 2x, plus 2 parentheses, and instead of, well, it's plus 3. The plus 3 had no x to change to parentheses. And then fill in the parentheses with the inner function. 3x plus 5, 3x plus 5. A subtle challenge for you, it is possible to start here. It's very possible. In fact, in the next video, I'll demonstrate it. All you have to do to start here is know which one to set up and which one to fill in. You set up the outer function, you fill it with the inner function. Let's clean this up. This will be a FOIL problem. If you were thinking of distributing the square, stop that! I've said in multiple videos prior to this that you cannot distribute a power across an addition sign. If you're not sure whether or not you can distribute a power, don't do it. Just do what the power says, which is to write it twice, and that will remind you it's a FOIL problem. I'm going to go ahead and FOIL it. We would get 9x squared plus 15x plus another 15x, which would be plus 30x, and then plus 25. A small distributive property move here, so plus 6x plus 10, and then the plus 3, and now we have a smattering of like terms. There is a 9x squared, but that's the only x squared. We have two x terms, a 30x and a 6x, so that gives us plus 36x. And we have not one, not two, but three constant terms. 25 plus 10 is 35, plus another 3 is plus 38. And you'll notice we got a completely different function in there. The only thing they have in common is that they're both quadratic functions with 3 terms. So function composition is pretty predictable once you understand what it is you're being asked to set up. Basically inserting one function inside of another. Now for full disclosure, function composition does bring unique domain issues, but for the purposes of this 3-week online college algebra class, I've decided not to focus on those. Although I think we would both see that the domain for both of these is just all real numbers, so nothing to worry about there.